Hello students, in the previous video we did proof of Leibniz theorem. Right now we are going to use the Leibniz theorem here to find the derivative of any integral equation. So right now they are just asking you to find the derivative of this function f of x that can be written as df by dx, or you can also write it as f prime of x. Now we have this integration from sine of x to the cosine of x, square root 1 plus t cube dt. Now we want to find its derivative, basically like d by dx of this integral. So how we can find its derivative? You can use the Leibniz rule here. You know that this integrand is your f of xt. Right now your f of xt is square root 1 plus t cube, and your f of x right now here is sine of x, and your beta of x is cosine of x. Now we are going to use all these values in this Leibniz rule. So this derivative, we can write it as df by dx as well, or we can write it as simple f prime of x. So f prime of x is basically finding the derivative of this integral, sine of x, cosine of x, square root 1 plus t cube dt. Now let's use this rule. So if you will use this rule, you have to do it integration from alpha of x to the beta of x. That is sine of x to the cosine of x. And the derivative of f with respect to x, we need here partial f over partial x. Partial f over partial x. Partial f over partial x. Do you see any x variable here? We don't have any x variable here. So complete derivative is going to be here 0. So it will be 0 dt plus, now your function f of xt, replace your t with the beta, that is cosine of x. In your function f of x beta, this was f of xt, now you need f of x beta. So in place of t, you are going to replace this cosine of x. So it's going to be square root 1 plus cosine cube of x. So let's plug in here. F of x beta is 1 plus cosine cube of x. Now you need the derivative of beta with respect to x. So derivative of beta with respect to x is minus sine of x. Minus, replace your function t value with the alpha. So in place of t, I'm going to replace the alpha. So it's going to be square root 1 plus sine cube of t. Now find the derivative of alpha with respect to x. So derivative of alpha with respect to x is just cosine of x. Now we need to just simplify it. So we'll get here minus sine of x square root 1 plus cosine cube of x minus cosine of x square root 1 plus sine cube of t. I hope you understand how to apply the Leibniz rule in finding the derivative. Let's do another example. Okay, fine. So in this question, this is your f of xt. F of xt is x minus t cosine of t. This is your f of xt, and I want to write alpha of x. So my alpha of x here is just the x, and my beta of x here is x squared. Now I need what? I need f of x beta. Okay, f of x beta is f of x, and what is my beta? X squared. So replace your t with the x square. So you will get x minus x square cosine of x squared. And another thing that I need here is f of x alpha. So f of x alpha. What is alpha? It's just x. F of x, x. So replace your t with the x. So it's x minus x cosine of x, that is 0. Now what else I need for my question? I need here derivative of beta with respect to x. So derivative of beta with respect to x is just 2x. And derivative of alpha with respect to x is 1. Now I got these values. Now I'm going to plug in these values in the Leibniz rule. So I will get here derivative of this function, that is f prime of x, equal d by dx of x to x square x minus t cosine of t dt. Now replace all these values in this formula. It's going to be integration from x to x square, then partial f. I need here partial f with derivative of f with respect to x. So let's find its derivative with respect to x. I can find it here. Partial f over partial x. So derivative of x is going to be just 1. So it's going to be, you can write it, or you can split it as well, like x cosine of t minus t cosine of t. So its derivative is just cosine of t minus 0. So let's use this value here. It's going to be derivative of f with respect to x is cosine of t dt, then plus f of x beta. F of x beta is x minus x square cosine of x square. So it's x minus x square cosine of x, and you need here d beta by dx. So d beta by dx is 2x. Minus, I need f of x alpha, and f of x alpha here is 0, and I need d alpha by dx, that is just 1. So let's integrate this as well. Integration of cosine of t is sine of t, and the limits of integration are from x to x squared. Let's simplify this one. So I will get here plus 2x squared 1 minus x cosine of x squared. I just took the x as common, multiply it with this x. Now apply the limits of integration here. So it's going to be sine of upper limit minus sine of lower limit plus 2x squared 1 minus x cosine of x squared. So I hope you understand how to apply the Leibniz rule in finding the derivative of integration. In the next video, we will do the how to solve the Volterra integral equation and Fredholm integral equation by using the Edomian decomposition method.